Hi everyone. Today we're going to study basic rules for limits involving infinity. The symbol for infinity, positive infinity or negative infinity, does not represent a real number. The symbol is used to describe the behavior of a function when the values are in its domain or range outgrow all finite bounds. For example, the function f of x equals 1 over x is defined for all x not equal to 0. Consider the graph of the function 1 over x. And this is the graph in blue. We can see that when x is positive and becomes increasingly large, the function 1 over x becomes increasingly small and near to the point 0. So we write the limit of the function 1 over x as x approaches positive infinity equals 0. Meanwhile, when x is negative and becomes increasingly large, the function 1 over x becomes increasingly small again and near to the point 0. And we write the limit of the function 1 over x as x approaches negative infinity equals 0. Since the right-hand limit is equal to the left-hand limit, then we write the limit of the function 1 over x as x approaches infinity. This time, this is a two-sided limit equals 0. Let us see the basic rules for limits involving infinity. For any number k and n, we have number 1, the limit of k as x approaches positive infinity. This is equal to k, that constant function itself. And the limit of k as x approaches negative infinity. This is equal to k. Then we say that the limit of k as x approaches infinity, this is now a two-sided limit, equals k. Number 2, the limit of x as x approaches positive infinity equals positive infinity. And the limit of x as x approaches negative infinity equals negative infinity. Number 3, the limit of the function 1 over x raised to n as x approaches positive infinity. The answer is 0. And the limit of 1 over x raised to n as x approaches negative infinity, the answer is 0. So we say that the limit of 1 over x raised to n as x approaches infinity, this is a two-sided limit now, equals 0. Number 4, the limit of x raised to n as x approaches positive infinity equals positive infinity. And the limit of x raised to n as x approaches negative infinity equals, the answer is positive infinity if n is a positive even integer starting from 2 onwards. Or the answer is negative infinity if n is a positive odd integer starting from 1 onwards. Number 5, the limit of 1 over x raised to n as x approaches 0 from the right. The answer is positive infinity. And the limit of the function 1 over x raised to n as x approaches 0 from the left equals, the answer is positive infinity if n is a positive even integer starting from 2 onwards. Or the answer is negative infinity if n is a positive odd integer starting from 1 onwards. Let us see this example 1. Evaluate the limit of the function 1 over x squared as x approaches 0. For our solution, let us remember the rule number 5. It says here, the limit of the function 1 over x raised to n as x approaches 0 from the right equals positive infinity, while the limit of the function 1 over x raised to n as x approaches 0 from the left is equal to positive infinity, provided that n is even and n is greater than or equal to 2. Considering our problem here, we can say that the limit of 1 over x squared as x approaches 0 from the right is equal to the limit of 1 over x squared as x approaches 0 from the left, and this is equal to positive infinity. Since our problem here is a two-sided limit, we can write now the limit of 1 over x squared as x approaches 0 equals positive infinity. Let us note this answer in here. Algebraically, we can observe the graph of this function. You can see here that when x approaches 0 from the right, the graph is going to positive infinity. While coming from the left, the graph is approaching a y value that is positive infinity also. So this is our final answer. Let us see this example 2. Evaluate the limit of the function pi square root of 3 all over x squared as x approaches infinity. For our solution, let us write again our problem, and then let us take note that our numerator here is a constant. By limit law, we can take this constant away while taking the limit of the function 1 over x squared. As you see here, we write pi square root of 3 multiplied by the limit of 1 over x squared as x approaches infinity. We note by rule number 3 that the limit of 1 over x raised to n as x approaches infinity equals 0. It means the limit of 1 over x squared as x approaches infinity equals 0. And we will substitute this value 0 for the limit here. So we have pi square root of 3 times 0. And the final answer is 0. Let us have example 3. Evaluate the limit of the function 2 minus 1 over x as x approaches infinity. We write again our problem here, and by limit law, we can take the limit of each term of the function. So we have the limit of 2 as x approaches infinity minus the limit of 1 over x as x approaches infinity. Take note that the rule number 1 says the limit of the constant k as x approaches infinity equals k. While rule number 3, it says that the limit of 1 over x raised to n as x approaches infinity equals 0. It means to say we can now solve the limit of 2 as x approaches infinity is equal to 2 minus the limit of 1 over x as x approaches infinity is equal to 0, and 2 minus 0 is simply 2. Considering the graph of this function, we can see here that when x approaches positive infinity, the graph is approaching a y value that is 2, while when x is approaching negative infinity, the graph is approaching a y value that is 2. So this is our final answer. Example 4. Evaluate the limit x squared plus 5 as x approaches negative infinity. Let us write again this problem here, and by limit law, we can express this by limit of x squared as x approaches negative infinity plus the limit of 5 as x approaches negative infinity. Let us note that by rule number 4, the limit of x raised to n as x approaches negative infinity equals positive infinity if n is an even number and it is greater or equal to 2, while the answer will be negative infinity if n is an odd number that starts with 1 onwards. And the rule number 1 says the limit of the constant k as x approaches negative infinity equals k. It means to say the limit of x squared as x approaches negative infinity is equal to positive infinity plus the limit of 5 as x approaches negative infinity is equal to 5. So in here, positive infinity plus the constant 5. If we add this, the constant will be consumed by the positive infinity behavior. So the final answer is simply positive infinity. This is our final answer. For a polynomial function, the limits at infinity or negative infinity are completely determined by its leading term. Leading term of the polynomial is the highest degree term of that polynomial. In symbol, for example, we have the limit of the polynomial as x approaches positive or negative infinity. This is equal to the limit of the leading term as x approaches positive or negative infinity. Example 1. Evaluate the limit of the polynomial negative 2x power 5 minus 6x raised to 4 plus 2x cubed minus 9 as x approaches infinity. Let us identify the leading term. The highest exponent here is number 5 with the term negative 2x raised to 5. So this is the leading term. Now, let us evaluate the limit of the leading term, the negative 2x raised to 5, as x approaches infinity. Let us substitute this infinity to the x. So we have negative 2 times infinity, that is raised to 5. This infinity raised to 5 is simply infinity. And this positive number that grows bigger and bigger, that is infinity, multiplied by the constant negative 2. So the answer is negative infinity. Example 2. Evaluate the limit of negative 4x raised to 5 plus 8x raised to 6 as x approaches negative infinity. Let us now identify the leading term. The highest exponent here is the number 6. So the leading term is this 8x raised to 6. Let us now take the limit of the leading term. Limit of 8x raised to 6 as x approaches negative infinity. Let us substitute the negative infinity to the x. So we have 8 times the quantity, the negative infinity, raised to power 6. We have the power here as even number. So the negative sign of the infinity becomes positive. We simplify this now as infinity. Now, the constant 8 multiplied by infinity is simply infinity. Example 3. Evaluate the limit of 10x raised to 5 minus 6x minus x raised to 7 plus 2x cubed as x approaches negative infinity. Let us identify the leading term. The highest exponent is number 7 with the term negative x raised to 7. So this is our leading term. Let us now evaluate the limit of this leading term. So we have the limit of negative x raised to 7 as x approaches negative infinity. Let us now substitute negative infinity to the x. So we have the negative of negative infinity raised to 7. Let us simplify this negative infinity raised to 7. 7 is an odd number, so when we simplify, the negative sign here of infinity remains. So it becomes negative of negative infinity. And negative by negative becomes positive.
Hi everyone. Today we're going to study principle of dominance on limits at infinity. Given the limit of this rational function p of x over q of x as x approaches infinity. This is case 1. when degree of the numerator equals degree of the denominator. Then the limit equals the ratio of coefficients of leading term. We have here three examples. Let's see example 1. The limit of negative 2x cubed minus x plus 2 all over x cubed as x approaches infinity. We can see that in the numerator, the degree is 3. In the denominator, the degree is 3. So they are equal. It means the limit is the ratio of the coefficients of the leading term. In the numerator, the leading term is the negative 2x cubed. So the coefficient is negative 2. In the denominator, there is only one term. That is the leading term itself. Therefore, the ratio is negative 2 over 1, which we can simplify as negative 2. Example 2. The limit of 5x squared plus 2 all over 3 minus 10x squared as x approaches infinity. In the numerator, the degree is 2. In the denominator, the degree is 2. So they are equal. Therefore, the limit is the ratio of coefficients of leading term. In the numerator, the leading term is the 5x squared. In the denominator, the leading term is the negative 10x squared. Therefore, the limit is 5 over negative 10. We can simplify this as negative 1/2. Example 3. The limit of x plus 3 all over 3x minus 7 as x approaches infinity. In the numerator, the degree is 1. In the denominator, the degree is 1. So they are equal. Therefore, the limit is the ratio of coefficients of leading term. In the numerator, the leading term is x. In the denominator, the leading term is the 3x. Therefore, the limit is the ratio of coefficients 1 over 3. These are the answers. We have case 2, when degree of the numerator is less than degree of the denominator. In this case, the limit equals 0. We have here two examples. Example 1, the limit of 7x cubed minus x plus 10 all over x raised to 4 plus 1 as x approaches infinity. In the numerator, the degree is 3. In the denominator, the degree is 4. We can see that degree of numerator is less than degree of denominator. Therefore, the answer is 0. Example 2. The limit of 5x squared plus 2 all over 10x raised to 5 as x approaches infinity. In the numerator, the degree is 2. In the denominator, degree is 5. It means degree of numerator is less than degree of denominator. The answer here is 0. These are the answers. Case 3, when degree of the numerator is more than degree of the denominator. Then the limit equals infinity or negative infinity. So this is now depending on simplified ratio. Let's have three examples. Number 1, the limit of negative 2x cubed minus x plus 2 all over x squared plus x as x approaches positive infinity. In the numerator, degree is 3. In the denominator, degree is 2. So, degree of numerator is more than degree of denominator. In this case, the answer is positive infinity or negative infinity. Now we will decide which one is the answer. We're going to test the x approaches positive infinity to the leading terms of numerator and denominator. In the numerator here, the leading term is negative 2x cubed. In the denominator, the leading term is x squared. Let us substitute the positive infinity to the x in the leading terms respectively. So it becomes negative 2 times infinity with power 3 all over infinity squared. There is this negative 2 multiplied to a positive infinity number, then divide by a positive infinity number. So the answer is negative infinity. Therefore, the answer for number 1 is negative infinity. Problem 2. The limit of x raised to 4 plus x cubed minus 2 all over x squared minus 3x plus 5 as x approaches negative infinity. In the numerator, the degree is 4. In the denominator, degree is 2. So, degree of numerator is more than degree of denominator. The answer is positive infinity or negative infinity. Let us see which one must be the answer. Let us test the x approaches negative infinity to the leading terms of numerator and denominator. In the numerator, the leading term is x raised to 4. In the denominator, the leading term is x squared. Let us substitute the negative infinity to the leading terms. It becomes like this. The fourth power of negative infinity all over the square of negative infinity. Since the exponents are even, we can simplify this as positive infinity raised to 4 over infinity squared. Then we can simplify this into infinity squared, and this infinity squared is simply infinity. In this case, the answer for number 2 is positive infinity. Now, problem 3. The limit of x squared plus 3 all over 3x minus 7 as x approaches negative infinity. In the numerator, the degree is 2. In the denominator, degree is 1. Therefore, the answer here is either positive infinity or negative infinity. Now let us test the x approaches negative infinity to the leading terms of numerator and denominator. In the numerator, the leading term is x squared. In the denominator, the leading term is 3x. So, negative infinity, that is raised to 2, all over 3 times negative infinity. In the numerator, the square of a negative number will be positive, and that is simply infinity. The 3 multiplied by negative infinity is simply negative infinity. And infinity divided by a negative infinity will give us negative infinity. So problem number 3, the answer is negative infinity. These are now the answers. The line x equals a is a vertical asymptote of the graph of the function f of x if at least one of the following statements is true. This is the first statement. This is about the left-hand limit. So this is the limit of the function f of x as x approaches a from the left equals positive or negative infinity. The second statement is about right-hand limit. So we write the limit of the function f of x as x approaches a from the right equals plus or minus infinity. To emphasize, we write here
This notation is the limit as x approaches the value a from the left, or we say from lesser values. And this notation is the limit as x approaches a from the right. Let us see this example 1. For the following exercise, examine the graphs. We're going to see 3 graphs here. We will identify where the vertical asymptotes are located. This is graph number 1. It seems that the asymptote or the vertical asymptote is located in here. So the equation of the vertical asymptote is x equals 1. Graph number 2. Let us examine the graph. We can see that the vertical asymptotes will come in here and in here. So the vertical asymptotes are x equals negative 3 and x equals positive 2. These are the answers. Graph number 3. Examining the graph, we can see that asymptotes will come here and here. So we write x equals negative 1 and x equals positive 2. These are the answers. Let's have example 2. Find the vertical asymptote or asymptotes of the function f of x equals x cubed over 4 minus x squared. We know that vertical asymptote of the graph of the function f of x exists if at least one of the following statements is true, meaning the limit of the function must approach positive or negative infinity when x goes to a certain value a, either from the left side or from the right side. Considering the function here, this will approach positive infinity or negative infinity if the denominator becomes 0. So what we're going to do, we're going to equate the denominator to 0 and we will solve for x. So we write the denominator 4 minus x squared and this will be equals 0. Let us solve for x. The negative x squared we will transpose to the right. So it becomes positive x squared. Then we will take the square root of the left side and the right side. So we will have plus or minus square root of 4 equals the square root of x squared. The left side becomes plus or minus 2 equals x on the right side. So the value of x are positive 2 and negative 2. Therefore, for the vertical asymptotes, we write here x equals 2 and x equals negative 2. These are the answers. Now let us consider the graph of the function. See now that the vertical asymptotes will come here and here. So this line is the x equals 2, while the other is the x equals negative 2. In this video, we're going to find horizontal asymptote by principle of dominance. Let us define horizontal asymptote. A horizontal asymptote, denoted by capital H, capital A, of a graph
is a horizontal line y equals b, where the graph approaches the line as the inputs approach infinity or negative infinity. Here is an example of horizontal asymptote. The line y equals 1. This is our graph. As the x goes to positive infinity, it approaches the line y equals 1. Also, when the graph approaches negative infinity, the graph approaches the line. So we see that the line y equals 1 is horizontal asymptote of this graph. Let us find horizontal asymptote by principle of dominance. Given the rational function p of x over q of x, here are the steps in finding the horizontal asymptote. Step 1. Evaluate the limit of the function p of x over q of x as x approaches infinity, and that is equal to capital L, using principle of dominance. Step 2. Write the equation of horizontal asymptote as y equals L. Note that when the limit is infinity, then there is no horizontal asymptote. Example 1. Find the horizontal asymptote of f of x equals 3x minus 1 over 2x plus 5. Let us take the limit of this function as x approaches infinity. By principle of dominance, since the degree of numerator equals degree of denominator, both degrees equals 1, then the limit is the ratio of the coefficients of corresponding leading terms. In the numerator, the leading term is 3x, so the coefficient is 3. In the denominator, the leading term is 2x, so the coefficient is 2. Thus, 3 over 2 is the limit. Then, the horizontal asymptote is y equals 3 over 2. Example 2. Find the horizontal asymptote of f of x equals 3x squared plus 2x all over 4x cubed minus 5x plus 7. Let us take the limit of this function as x approaches infinity. By principle of dominance, since the degree of numerator is less than degree of denominator, then the limit is 0. So the answer here is 0. Then horizontal asymptote is y equals 0. Example 3. Find the horizontal asymptote of f of x equals 3x squared plus 4x over x plus 2. Let us take the limit of this function as x approaches infinity. By principle of dominance, since the degree of numerator is greater than degree of denominator, then the limit is positive or negative infinity. So, plus or minus infinity, we write it here. Therefore, in this case, there is no horizontal asymptote.